We find that we need to be at the right location in the galaxy, that we're inside the circumstellar habitable zone of a star, that we're in a planetary system with giant planets that can shield the inner planets from too many comet impacts, that we're orbiting the right kind of star that's not too cool or not too hot, that we're on a planet that has a moon that can stabilize the tilt of its axis, that we're on a planet that's a terrestrial planet, a planet that has a crust that's just thick enough that it can maintain plate tectonic activity, that has enough heat in its interior that it's still circulating its liquid iron core so it can generate a magnetic field, that it has an atmosphere that has enough oxygen to allow for complex organisms to survive, that it has enough water and enough continents to allow for the diversity of life or an active biosphere that you need to support complex creatures such as ourselves. All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life.
In an attempt to estimate the probability of attaining this combination of factors simultaneously, some researchers have developed equations assigning a conservative 1 in 10 value to each factor deemed necessary for advanced life.
If every element has to be there at the same time, you have to multiply the probabilities, and that's what makes the probability at the end so small. You've got 10% of this and 10% of that, and these things rapidly multiply to exceedingly small numbers. The numbers on the order of 10 to the minus 15, which is 1/1000th of 1 trillion. And it's a number like that that you have to compare to the 100 billion stars that are in the galaxy. 100 billion is a very large number, but 1,000th of a trillionth is much, much smaller. On their face value, these probabilities are speaking. What they're telling us is this can't happen, or this is very unlikely to happen in the galaxy. And that's where the evidence is pushing us.
There are many probabilistic resources in the galaxy, but on the other side of the coin are all these factors that you need. You have to get just right in order to have just one habitable planet like the Earth. And that leads me to conclude that yes, we're rare in the galaxy.
While a growing body of scientific evidence may support this hypothesis, does the possibility that our planet is rare within the galaxy imply anything about its significance? Recently, astronomer Donald Brownlee considered this question in the best-selling book Rare Earth: Why Complex Life is Uncommon in the Universe.
There's a general feeling that nature wants to make Earth-like planets, and that naturally that life will evolve on them and naturally evolve to something like us. And yet the conditions, the environmental conditions on the planet that would allow more complex creatures similar to people, or plants and animals, is very rare. And so we wrote the book Rare Earth to point out that the Earth is actually a rather special place.
Brownlee contends that while relatively simple microbial life may thrive on planets throughout the universe, planets capable of sustaining complex life are exceedingly uncommon.
Well, the entire universe is highly hostile to life. If you compare all the known places in the universe, none of them compare to Earth. We live in a very special environment that provides what we need, provides air, provides food, stable conditions, so that the Earth is almost like a giant organism where its systems are interacting in a way that allows animals to survive. The real question is, why did this happen? Was it just a matter of luck or not? If you look at thousands of planets, only a small fraction of them, very small fraction, will be truly Earth-like. So if we are very rare, we did win the cosmic lottery. So we're a lucky planet. We're just in a very fortunate place.
When you consider chance as an explanation for a planet like Earth, you have to look at it in the context of the universe as a whole. While the odds appear astonishingly small that you'd get all the right ingredients to support complex life at this one place in the galaxy, you have to keep in mind that our galaxy is just one of perhaps 100 billion galaxies in the observable universe. Still, logically, I think you have to ask yourself, what if this convergence of factors didn't come about as the result of simply a cosmic lottery or a mere fluke or luck, but what if it's the result of some larger underlying purpose or design? And if the Earth does exist for a purpose, is there any way that we could tell?
On October the 24th, 1995, a rare natural phenomenon unexpectedly triggered a unique search for an answer.
Oh, look at this, guys!
It started with an experience I had in 1995. I went to observe a total eclipse of the sun in India. It was my first and still only total eclipse of the sun. It was a spectacular event. It's just an experience for all the emotions. Either astronomers who can understand the whole phenomenon can predict it to within a second of time anywhere on the Earth, or a local native are equally in awe and reacting in the same way to this incredible phenomenon. It really left a big impression on me.
For 51 unforgettable seconds, Guillermo Gonzalez and thousands of others looked on in wonder at this rare astronomical event. Gonzalez would later reflect upon both the mysterious beauty he had witnessed in the North Indian skies and the factors that had made it possible.
Fabulous! Fabulous!
The requirements for producing a total eclipse of the sun are a luminous body, in our case the sun, an eclipsing body, in our case the moon, and then an observer platform, in our case the surface of the Earth. And they all have to be in a straight line in space. The apparent size of the moon in the sky has to be almost exactly the same as the apparent size of the sun in the sky. They're both about half a degree. The sun is 400 times bigger than the moon, but it's 400 times further away. So there's this coincidence people have noted for centuries, but they just say, oh, well, it's a coincidence, and shrug their shoulders.
As Gonzalez examined this rare alignment of sun, moon, and earth, he recognized the importance of these celestial bodies to the existence of complex life on our planet. The gravitational pull exerted by our moon, for example, is strong enough to regulate the Earth's climate by stabilizing its tilt and helping to circulate the warm and cold waters of its oceans, while our planet's distance from the sun permits both liquid water and an oxygen-rich atmosphere.
You have to have the right distance of the observer's home planet from its host star, and you have to have a large moon, and so there's this very strong overlap between the requirements for producing eclipses and the requirements for habitability, for having a planet that can support life.